So, can you draw a mechanism for the following reaction? Methanol and an acid chloride. We know methanol is a good nucleophile. It adds in. We don't have to draw the phenyl out. We can just draw it as a pH. Get this. And then from there we can reform the carbonyl kicking out the leaving group. And we have the protonated ester. And then from there we can use our pyridine to grab the extra hydrogen to get to the neutral compound. Okay. They're all, remember, all those mechanisms are the same as we're going along. So predict the products. Thionyl chloride makes the acid chloride. Ethanol is going to take the acid chloride and make the ethyl ester. Ammonia is going to take the acid chloride and make the amide. And then we're going to make the mixed anhydride with acetic and benzoic acids. So it's going to be the benzoic acetic anhydride. We can take an anhydride and we can cleave it, and one thing we get is the carboxylic acid, and the other thing we get is an ester, methyl ester in this case. We're going to get, if we just have ammonia, we'll get the carboxylate, since we probably have an excess of it, and the amide. Here we're going to change it to the methyl ester, and we're also going to end up with the benzyl ether out of the reaction. Here we're going to end up with the methyl ester and the benzyl alcohol out of it. Then the amide with base followed by acid is going to cleave it to the carboxylic acid. Same if we do it the other way. P4O10 is a dehydrating agent. It's another way to turn it into a nitrile. Okay, then we have the amide, nitrile. We turn it, it goes through the amide into the carboxylic acid with either acid or base followed by acid. We're going to get the carboxylic acid out of it, and then the bromine, phosphorus, and water gives us an alpha bromo acid out of the process. Okay, so now we'll draw some mechanisms. So we know with the thionyl chloride and sodium carbonate, we get the acid chloride. So the carboxylic acid reacts with the thionyl chloride, send the electrons up to form the tetrahedral intermediate. That gives us double bond, single bond to the sulfur, single bond to the oxygen with two chlorines off of it, and ROH of our acid with a positive charge on the oxygen. We can reform the SO double bond, kicking off the chlorine, which gives us this. Now this chloride can add to the carbon because we have a really good electrophile, breaking the double bond. Whoops. Oh. So that gets us to the tetrahedral intermediate. Then we can reform or form a double bond, kicking off all the stuff as a leaving group. And then our pyridine come grab a pyridine, carbonate. Carbonate can come grab a hydrogen to form the acid chloride. Okay, so there's the mechanism for the formation of the acid chloride. Then if we add ethanol, we can add it in, form the tetrahedral intermediate. We can reform, kick off the chlorine. And then we can use our pyridine to grab the extra hydrogen to give us our ester. And the middle two steps are interchangeable. We can remove the hydrogen first, or we can kick off the chlorine. It doesn't matter. So we can add the amide into the acid chloride, form the tetrahedral intermediate, reform the carbonyl, kicking off the chlorine, giving us the protonated amide, and then another equivalent ammonia can come in and grab our hydrogen to give us our amide. The acid chloride and carboxylate. Carboxylate can add in, form the tetrahedral intermediate. We can reform the carbonyl, kicking off the chlorine, and we're done. We have our anhydride. If we have an anhydride, we can add methanol in, break the double bond. Reform the carbonyl, kicking out our leaving group, carboxylate, which gives us the protonated ester. And then our carboxylate can grab that hydrogen to give us the carboxylic acid and our ester. We can do the same sort of thing with an amine, adding to our anhydride, form the tetrahedral intermediate, reform, kick off the leaving group, carboxylate, weak base, which can then grab the extra hydrogen off of our amide nitrogen, and it gives us the carboxylic acid along with the amide. And then if we have an ester and add acid to it, we protonate the carbonyl to make it a good electrophile. Our methanol adds in, breaking the carbonyl. Remove the extra hydrogen with our methanol to get to the neutral tetrahedral intermediate. Protonate the O-benzyl from our acidic methanol. And then reform a carbonyl, kicking out our leaving group. And then remove our extra hydrogen to get us to our methyl ester. And we also have that benzyl alcohol around that we formed 2 steps back. Okay, that's acid catalyzed, a lot of proton transfers. Base catalyzed, we added in, formed the tetrahedral intermediate. Reform the carbonyl, kick out our leaving group, and we are done with the first step. And then we add acid, and we're going to protonate our alkoxide to give us our benzyl alcohol. And then we have the amide cleavage with base. Be careful, make sure it fits. Add it in, reform the carbonyl, kick out the leaving group. That gives us the carbonyl with the OH. The OH is going to grab that off to give us the carboxylate. And then we add acid in the workup, protonated, and we get the carboxylic acid. Okay, that's the short way. Then we have the long way with acid, where we have to protonate it first with one of the protons off of water. Then water can add to the carbonyl, form the tetrahedral intermediate. We can remove the extra hydrogen to give us to the neutral. We can, protonate the wrong thing. Protonate the nitrogen, because that's what we need to get rid of. Reform carbonyl, kicking out nitrogen. That gets us to the protonated carbonyl. And then we have our NH3, which grabs the extra hydrogen. And we get to our carboxylic acid. And then the last one with either acid or base with the nitrile. If we're in acid, protonate. Add water in, break the triple bond. To give us the double bond with the nitrogen. Remove the extra hydrogen. We can protonate the nitrogen. Almost did the resonance structure too quick. Then draw the resonance structure. We want to make sure we have a positive charge so we don't get a negative charge when we do this. That gives us the protonated carbonyl and the NH2. We could remove that extra proton to get to the amide. We'll leave it on there because we're going all the way to the carboxylic acid. Add the water in. That gets us to the tetrahedral intermediate. Remove the extra hydrogen. Protonate the nitrogen. To make it a good leaving group. Make it leave, giving us the protonated acid. And then ammonia can grab that extra hydrogen. It's a 3. To give us our carboxylic acid. Enter the acid catalyzed. Okay. The base catalyzed wouldn't have all the proton transfers in it. It would still have a few, but not near as many as the acid catalyzed. So the base catalyzed, we added in, form the N minus with the OH. We're going to protonate the nitrogen to make the molecule neutral. Remove the hydrogen of the oxygen. Draw a resonance structure. Okay. Then from there, we can protonate that. Make the neutral amide, excuse me. Then we can add hydroxide in, break the carbonyl, reform, kicking out the NH2 minus, which gives us the acid, and an NH2 minus, which is a strong base, which is going to grab the extra hydrogen. So before we work this up with acid, with just base around, we get to the carboxylate, and then we add acid to work it up, and we're going to get the carboxylic acid. Okay, so there's the mechanisms for this section. If you have any questions, send me an email, watch the video, come by and ask questions in class. However you want to ask them, feel free to ask all the questions you need. Talk to you later. Bye.